So we move to chapter 22, Summarising and Analysing Data. This particular chapter falls into two parts, really. In the first instance, definitions and memorising definitions. And in the second instance, some slightly complicated formulas that, we're provided with in the exam, but we need to practice using. They're a little bit tricky. Let me explain. First things first, when we think about data, or indeed understanding data, what the chapter does and what the ACCA want us to do is to be able to define data in different forms. So let's take a look at the first area. Let's think about structured and unstructured data. Now I'm going to make reference here to data analytics and indeed big data in a moment, but in essence, when we think about structured data in a sort of basic sense, really what we're talking about is data in a standardized format. Relationship databases, spreadsheets, etc. So, for example, if you're working in finance or accounting, an accounting system would in effect house structured data, whether that relates to sales, purchases, bank transactions, etc. The second area for us, and the second area of definition, is really semi-structured data. So really, semi-structured data, as you'll see from the description here, not quite a sort of a fully standardized format, but some elements make it easier to analyze than completely unstructured data, as we'll see in a moment. So broadly speaking then, it's a mixture of structured, as we've just seen, and indeed unstructured. So what might be an example? Let's say a photograph, a digital photograph. In effect, I guess the image itself would be unstructured. You could have 1,000, 1 million different images, but there is some data that is easily understood. So for example, the date and the time, that would be structured. Moving on to the sort of third definition, as it were, unstructured data. So various formats and pretty difficult to sort of fathom, analyze and indeed manage. So let's say a video, for example, or a sample audio data in relation to, say, weather, completely unstructured and to some extent unpredictable. Okay, so there's our sort of intro. As mentioned, I'm going to refer this back to sort of data analytics to try to make it live for you in a moment. Let's move on to the next area of categorical versus numerical data. Now again, the terminology may be familiar to you, but the concepts aren't overly complex. When we think of categorical data, we're thinking about data that is, broadly speaking, sort of descriptive. It describes rather than numerical. And it's often sort of divided into groups or categories. So say, for example, you might have race or maybe even age, okay? It's descriptive rather than numerical, okay? Outside of that, when we think of different types of categorical data, firstly, nominal data, i.e. data that really can't be ordered in any way. So, for example, the industry that its business is in, let's say tuition or car manufacturer, etc. But there's no particular order to that. There's no particular order to industries. Industries are just industries. Okay. Now, converse to that, really, ordinal data. So this is categorical data with some form of set order from lowest to highest. So say, for example, a customer survey, we could ask customers to rate a product from, say, 1 to 10. That would be ordinal data. Okay? So far, really, definitions. Let's look at numerical data. Now, this is something that's probably a little bit more familiar to you. So let's say something like weight, height, etc. Described using numbers. Now, note that continuous data is numerical data that can have any value, okay? And continuous data is measured rather than counted. So, for example, height, weight, length, etc., etc., okay? Note, converse to that, discrete data is uncountable and cannot be more precise. So for example, the number of something, the number of children, number of cars, sales volume, etc., etc., normally whole numbers. Okay? Moving from there, as mentioned, data analytics. Now, we started off by talking about sort of structured data, unstructured data. And when we think about big data, just making this live, where you think about a supermarket, the many, many forms of data that a supermarket will receive. Point of sale, email, text, in writing, in person, etc., etc. So that idea of structured versus unstructured data, if we link it to that, really what supermarkets get is a number of different forms of unstructured data coming in. What they do is process it to structure it. Now, when we link that into data analytics, obviously what data analytics is in effect the idea that we're trying to derive some benefit, let's say, from a set of data. So, for example, we could use different types of analysis. For example, a supermarket might look at seasonality. They might look at Christmas sales. They might look at children's products, children's clothes, etc., etc. Okay? Now, there's two types of analysis in this particular area. The first one being descriptive, which really broadly just explains or summarizes what the data actually shows. For example, the mean, the median, mode, etc. But there are many, many other examples. So that's descriptive. Now, inferential, slightly different. What we're trying to do is produce theories based on the data or conclusions. So, for example, regression analysis. Maybe we're trying to forecast forward next Christmas's sales of a particular product. Okay? So there's the link between types of data and indeed something that you may be familiar with, i.e. big data. Okay. Now, in terms of averages, several sort of areas here that we need to be on top of. So, in essence, what the examiner will do is present us with scenarios, obviously, and ask us to do the calculations. The calculations, I don't think, for mean, median, and mode are overly complex. They're broadly all linked to sort of the average of something. I guess the easiest one to think of is the mean. Yeah. So really, the mean, in terms of the formula, we'll see basically the sum of the items over the number of items, and denoted by really sigma n. Okay, with n being the number of items. Okay. You're also familiar, if you've been through the study hub, with the term frequency distribution tables, and often it's easier to present information in a table. Okay. Now, in terms of mode, what we're talking about is really the most frequently occurring value in a given data set. Let's make sure that we know the difference between these three, and indeed how to calculate it. The median, again, slightly different. Really, the average that represents the middle item in a set of data in increasing order. So let's learn off not just the definitions so far, but certainly the definitions of mean, mode, and median. Slightly similar, slightly different. Okay. Moving from there, in terms of the mean of grouped data. So what we're talking about here is really data that is collected and recorded in class intervals. Don't let that term scare you. It's just a group. Okay, so for example, if we have a class interval of 0 to 5, clearly we've got 5 values more than 0. In effect, when we look at the sort of midpoint there, we would say 3. So really, when data is grouped in this way, the midpoint is fairly straightforward, fairly easy to calculate. Okay. Let's move from there into sort of measures of dispersion. Now, when we think about measures of dispersion, we're thinking about, broadly speaking, I guess the difference between averages and sort of outliers in one sense. So, averages really give an idea of the central point of a set of data values, but they don't really give an idea of how spread out the values are. So key terms here really are range, which I'll explain in a moment, and also variance. Now, in terms of range, what do we mean? It's just the word that you'll be familiar with. Really, the difference between the highest and lowest values in a set of data. That's the range, high to low. Outside of that, when we think about variance, a little bit more complicated here. We'll slow down a little bit. Really what we're talking about in terms of the variance is really the spread of data values in a given data set. Okay? So it, broadly speaking, sort of measures how far each value in the set is from the arithmetic mean. You'll recall the mean calculation up above. Okay? So the variance is known as sigma squared, so denoted by this little fella here. Okay, note that obviously sigma is the capital letter for the Greek character sigma, and sigma squared is basically lowercase. Okay, so in terms of the formula, it looks quite complicated, but it's not overly so. So if we were wanting to find the variance of ungrouped data, we would work really as follows. Now we'll see variance ungrouped data, basically sigma, the data value, I being the x minus x, or the mean, okay, multiplied by 2, divided by n, the number in the set, okay? So for these formulas, particularly this one and the ones that we'll see going forward in this particular video, the thing to do, I think, is to write the formulas down and let's get practicing. I think a certain amount of theory is helpful, but without sort of getting the questions wrong or exposing yourself to questions, I think the theory is not going to make a lot of difference to you. Okay, so my suggestion here with these formulas and the ones we'll see in a moment is practice. Okay, so this is a summary of really everything that we've talked about so far, broadly speaking, certainly over the last few branches. Okay, so I'm going to leave you to cover that. Let's get into the next area, which is measures of dispersion, standard deviation and coefficient of variation. Now, when we think of a standard deviation, in line with what we said above, really what we're talking about is the spread of data around the arithmetic mean. So really, it's the square root of the variance, and indeed can be calculated as follows. Okay, so standard deviation, group and ungrouped, square root of the variance. Okay, now the higher note, the standard deviation value compared to the arithmetic mean, the more dispersed the data. Try and remember that. The higher the value, the more dispersed the data. Okay, moving from there, in terms of the standard deviation of ungrouped data, this formula is provided in the exam. Again, we don't need to rote learn it, but my thoughts on this formula and indeed group data below, which is here, is yes, provided in the exam, but practice is what we need to do, because the way in which the examiner will present this information in the question will vary from question to question. So that's the key for us. Okay, moving from there, in terms of the coefficient of variation, let's define that first. Really, we're talking about two data sets, a measure of dispersion that compares the spreads of two or indeed more data sets. Okay, so the coefficient of variation, it's also known as the coefficient of relative spread. Okay, and it's calculated as follows: standard deviation divided by the mean. Now, I do think when students, MA students, come across these areas and these formulas for the first time, they may look at them and think, well, this is all a bit confusing, I'll avoid them. Let's not, because the examiner knows where it hurts. The examiner, for example, is providing these formulas in the exam for good reason, because he knows it gives him an opportunity to set difficult questions. He's not going to make you learn a formula that's difficult and do a question that's difficult. These areas are definitely examinable, so try not to avoid them. Okay. Moving from there, key point here: higher the value of coefficient of variation, the wider the data spread, as we said above. Okay. So, in terms of comparing populations, if we were to use the coefficient of variation to compare different populations, what we see in this first branch here is, as we said above, basically we're talking about measuring the spread of data around the mean. Now, if we were in a position where we wanted to sort of compare relative spreads, we must calculate the coefficient of variation. Do remember that, okay, if we're talking about two or more data sets. Okay, let's move now into the normal distribution. This may be something that you're familiar with, possibly in relation to past math studies or another exam. Some areas of it initially quite straightforward. The form is a little bit tricky. So what do we mean? Well, what we're saying in the first instance is that data of any kind can be spread out, as we've seen, in a number of different ways. Okay, now let's talk about one way, a normal distribution. And now, what would a normal distribution have? Well, broadly speaking, symmetrical. Okay, think bell-shaped curve. Note, obviously, as you see the diagram in the study hub, the area under the curve is equal to 1. And in effect, you've got a sort of that little curve going from, let's say, left to right, if you will, with the bump in the middle. That would be a normal distribution. I think the example they use in the study hub is, let's say, height in a given classroom. So in terms of interpretation, really, in effect, we can sort of, in effect, measure the distribution or the spread around the mean using the standard deviation. As we've said, we know that the area in the curve is 1. And note, obviously, regardless of the value of the mean and the standard deviation, provided the same number of standard deviations for the mean is measured, it'll always divide into the same proportions, left and right of the middle. Okay? Now, as mentioned earlier on, we talked about formulas being given in the exam. Let's talk a little bit about the normal distribution tables now, as you'll see referenced within the study hub. So, the table given in the exam shows the area under the normal curve between the mean and point Z standard deviations above the mean. Let me just move this down so you can see this. So I've just taken this directly from the study hub. Okay? Now, do we think that we would get questions on this diagram? Very, very possibly. Now, in terms of the detail here, in terms of the formula that's provided, I think the key point here is what I mentioned earlier on about use of the formulas or learning the formulas. I think there's one thing being able to look at the formulas in the table. It's another thing being able to use them because of the way in which the examiner presents the information. So again, you've heard me say this 1,000 times in this course, the only way to deal with this is practice. Okay? So that concludes chapter 22. For me, as I said from the off, split into two main areas: definitions and then trickier bits, i.e. the formulas. Let's memorize the definitions as best we can. Those questions are what I would call low-level, cheap marks. In terms of the formula side, I think they're tricky, the questions, even if we have practice. So first port of call is practice first. Remember that we don't need to get every question right, okay? I hope that made sense and that your studies are going well. Many thanks for listening.